So we're going to do some more integration examples. So let's look at the following. Let's evaluate the integral of x plus 1 over square root of x dx. Now here we have a quotient, and if you remember, taking derivatives of quotients is complicated because we have to use the quotient rule. So the same thing kind of applies here. Integration of quotients is complicated. And so if we can simplify this so that there isn't a quotient, we're not dividing anymore, that would be great. And so what we're going to do is split this up into two terms, x over the square root of x and 1 over the square root of x. And so here you're going to simplify. You'll get x to the 1/2, and this will be x to the negative 1/2. And now you're going to do the reverse power rule here. So this will be x, if you add 1, it'll be 3/2. If you add 1 to negative 1/2, you'll get a positive 1/2. And don't forget the plus c. So now if you want to, you could bring up your fractions. 2/3 x to the 3/2 plus 2 x to the 1/2 plus c. And there is my answer. So if you can, simplify what's inside of the integral so that you no longer have a quotient anymore. Let's look at an example that involves a trig function. Let's evaluate the integral of sine x over cosine squared. So what I'm going to do here is take my sine x over cosine squared, and I'm going to split this up into a sine x over cosine x times 1 over cosine x. So I'm going to split up the squared in the denominator. It's here. I'm going to split it up into two pieces. And then we're going to remember that sine over cosine is tangent, and 1 over cosine is secant. And then think about which function has derivative, tangent times secant, and that function is secant plus c. So when you have trig functions, you might need to use your identities to rewrite your trig functions and break it down into something that you can find the integral of. All right, and one more integral example here. Let's find the general solution of f prime of x equals e to the x, and find the particular solution that satisfies the initial condition f of 0 is 3. So the first thing we're going to do is we were asked to find the general solution. So to get capital F of x, we're going to compute the integral of f prime of x, which was e to the x. And remember that the derivative and the integral of e to the x is itself e to the x plus c. So this right here, this is our general solution. And now we're going to find the particular solution that satisfies this condition, f of 0 equals 3. So we are going to focus in on that initial condition, f of 0 equals 3. So I'm going to plug in x equals 0. And I'm told that f of 0 is 3, e to the 0 is 1. So you can now solve for c. c is going to be 2. And so our particular solution is going to be e to the x plus c, which is 2. So this is our particular solution.